Big question. How did life on Earth begin? Today, many origin of life researchers believe that the first living organism evolved in a primordial ocean when, theoretically, small particles of non-living matter came together to form one self-replicating cell. By randomly bonding through the blind interactions of matter, energy, and a huge dose of luck.
When you come to the origin of life, this is the underlying philosophy. The rules say to solve the problem, you can use matter and energy and natural law and chance processes, but that exhausts your toolkit. What you're not allowed to use, fundamentally by the rules, so-called rules of science, is mind or intelligence.
Okay, so working under these limited parameters, could you actually build that first living cell? To find out, let's start with the basics. We know that, like its modern counterparts, the structure of the first cell would have included proteins, large non-living molecules found on the cell's outer membrane and the biological machinery inside. By isolating one of them, we discover that each protein is built from hundreds of even smaller molecules called amino acids, 20 different types of which have presumably been used to build every protein in every cell, including the first one.
Without proteins, there is no life. So if we're going to understand the origin of life, a great place to start is with the basic chemistry of protein molecules.
The construction of a protein begins when specific amino acids are organized into a chain. It's a process often compared to arranging alphabet letters into meaningful words and sentences. If each amino acid is properly sequenced, the chain folds into a protein fully equipped to perform its task within the cell. But if the amino acids are arranged in the wrong order, the chain won't fold correctly and is eventually destroyed. Now, let's apply these facts to a familiar theory for the origin of life. Scientists have long speculated about primordial oceans loaded with amino acids that floated around like bumper cars. Perhaps, over time, some of these random collisions produced a chain long enough to fold into a small functional protein molecule. Later, more amino acids linked into more chains that folded into even more proteins. Eventually, enough proteins, along with other components, organized themselves into the first living cell.
Now, if you're a die-hard materialist with a vivid imagination, you might be able to convince yourself that an explanation like this is feasible. That somehow all of these precise chemical interactions and assemblies could have occurred without any plan or direction. But realistically, what are the odds that even a single protein molecule, not an entire cell, just one small part of a cell, could form through blind, undirected chemistry? The mathematics are staggering.
Researchers have calculated that on the ancient Earth, the probability a random process could produce just one small protein of 150 amino acids was 1 chance in 10 to the 164th power. That's one correctly sequenced protein chain for every 100 million trillion 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 failed attempts.
When confronted with these seemingly impossible odds, evolutionary scientists often turn to their ultimate life preserver, time. If you have enough time to work with, then at least in theory, any improbable scenario is possible, regardless of how unlikely it may seem.
To test such reasoning, let's hypothetically establish an ideal environment for chemical evolution. An imaginary world that could provide chance with every opportunity to succeed. Then we'll turn the chemistry loose to see what happens. The amino acids start bonding furiously. In our experiment, an entire chain of 150 units self-assembles in only 1 second. If their sequence is incorrect, the chain is immediately destroyed and a new assembly begins. Throughout the planet, 6,000 million billion trillion attempts will take place every minute. That means in 4.6 billion years, the oldest estimated age of the Earth, the number of protein chains that don't fold could exceed 10 to the 58th power. It's an unimaginable total, but nowhere near 10 to the 164th, the trials necessary, on average, to build a protein of 150 amino acids by chance. So, if undirected chemistry can't produce our coveted protein during the entire history of the Earth, then how much time would have been needed? To find out, let's take a road trip. We'll start by erecting a bridge that spans the diameter of the observable universe, a distance of more than 90 billion light years. Then we'll place an amoeba on one end of the bridge. This single-celled organism will travel at the breakneck speed of 1 foot per year. It's off. While we wait for one protein to form by chance, the amoeba slides along for more than 5 billion years to cross the entire universe and then return. But we're just getting started. The amoeba takes off again, successfully reaches the far side of the cosmos, then heads back home. Yet not even one functional protein is anywhere in sight. For the next trip, we'll add a payload, a single atom. After inching its way another 500 billion trillion miles, the amoeba drops off its cargo and returns for more. Will it get back before our lucky protein forms? Absolutely. In fact, it will complete another 10 round trips, then 20, 100, 1,000. And there's still no sign of a usable molecule. The amoeba continues making round trips until it has hauled off every atom on Earth. Then, all of the atoms in our solar system. Then, every planet and star in the Milky Way galaxy, one atom at a time. In fact, as we wait for one protein to self-assemble, the amoeba has so much time that moving at just 1 foot a year, carrying 1 atom per round trip, it will transport the entire universe more than 56 million times. If you're counting on chance, that's how long it would take to build one functional protein.
Now, suppose against all odds, chemical evolution produced our single functional protein. Would we have life? No. We'd have one protein, just a lifeless arrangement of amino acids. The simplest living cell we know has more than 300 different proteins. But proteins are only part of the story when you consider any actual cell. Remember, you're going to have carbohydrates, complex sugars, nucleic acids, DNA and RNA, lipids, a whole variety of different chemicals which jointly constitute the living state. those bits and pieces all have to be brought into the same microenvironment at the same moment in time.
What can you say? The probability that you would get them in the same space at the same time becomes beyond unimaginable. And the probability that you would get them within a membrane enclosure, like a cell, is the next best thing to impossible. There's simply no way that matter, energy, and blind chance can produce the complex molecules required for the first life on Earth. Instead, intelligent design is the only realistic cause for the first life and for all life that has ever existed.